Hello children. In first topic of sound chapter, we had studied that what is sound, speed of sound, how sound is produced. So now in next topic, let's see the activity to show that sound is produced by vibration, and sound is that form of energy which sets something in vibration also. So for that we take a cardboard box, rectangular cardboard box, and we remove the two ends of the box, and on one end we fix a balloon. On that balloon there will be mirror, plain mirror will be here, and this one will be the balloon. Now we keep a screen at some distance from this cardboard box, and then we tell someone to light a torch from here. You see, torch from here, a ray of light will fall on the mirror, and what will happen that the ray will get reflected and will find the spot on the screen. Ray of light from the torch will fall on the mirror fixed on the balloon, and then it will reflect back, and we will see here the reflected sound light here on the screen. Now what happens from this side, we produce sound softly. First softly, then little bit we go on increasing the loudness of sound. So as we start producing sound from this side, what we find that the spot of light on the screen starts vibrating. As the loudness of sound goes on increasing, vibration of a spot of light also goes on increasing. So we are doing nothing here. What we are doing, we are producing sound from this side, and due to that the spot of light vibrates, and that proves that sound also sets something in vibration. And if you speak something, put your finger on the throat, you will feel vibration on the throat. If we keep our finger in front of our mouth while speaking, we will feel little bit pressure on our fingers, on our hand. So these things show that sound sets something in vibration. Sound is produced by vibration, and also sound sets something in vibration. Okay, so this thing is clear, I think so. Now in this topic only there is a term vibration and oscillation, children. So let's again recall the example of pendulum. We had studied this thing in class 7 and in class 8 also. Now this is the A is the mean position of pendulum. Okay, where and suppose the pendulum is at rest and it is at mean position at A. Now we displace the bob of pendulum and bring it at B and leave it. What happens? The pendulum starts oscillating about the mean position. It reaches at C. So it executes to and fro motion about the mean position. And in this one also we had studied that maximum displacement of bob from mean position to one of the extreme position is called amplitude. AB or AC is called amplitude of vibration oscillation. The AB or AC is amplitude. Now when the pendulum is set to complete one oscillation, when it moves from mean position to one of the extreme position to mean position, again to another extreme and back to mean position, then pendulum is set to complete one oscillation. Okay, So one complete to and fro motion of oscillating object about its mean position is called one oscillation. Next term, time period. Time taken to complete one oscillation by the pendulum is called time period. Time taken to complete one oscillation. So time taken by the pendulum to move from A to B, B to A to C, again back to A is called one oscillation. And time it taken is called time period. Now in 1 second, number of oscillations completed by pendulum is called frequency. If you want to note down, you can note down while I am speaking, and then your notes will also be ready. So this kind of motion is called oscillatory motion, oscillation. Then one more thing here, that if we consider an example, suppose this is the surface of table. On this table we keep a ruler. This is ruler. This is ruler. We press this end of the ruler and then pluck it. Push it up or down and then leave it. What happens? This end of ruler starts executing again to and fro motion about its mean position. These are the two extreme positions of ruler, plastic ruler. Again, this will be the amplitude of vibration or oscillation, what you said. Now what happens? As we move towards this end of the ruler, amplitude goes on decreasing. Amplitude goes on decreasing, and over here we see that molecules of this end won't get displaced. So over here also we see that there is to and fro motion of the molecules of ruler, but what happens? The amplitude goes on decreasing as we move towards the fixed end. But in case of pendulum, it doesn't happen. All the molecules of pendulum get displaced by same amount in same time. So this is the difference between the two. This is oscillatory motion and this is vibratory motion. Again, one more example, children. We have a stand here, two stands here, and we tie a string between the two stand. Okay, this is the mean position of a string. Now we pluck the string from the middle. What happens? We see that the string starts executing this kind of motion like this. So the motion of this string here is oscillatory or vibratory. I think if you have understood, then you will say it is vibratory, because the amplitude of the molecules of a string goes on decreasing as we move towards the fixed end of the string. So here what we see that there is difference between oscillatory motion and vibratory motion. So whenever there is oscillatory motion or vibratory motion of an object, sound is produced, whether the sound is feeble or louder, but the sound will be produced. Sometimes we will be able to hear that sound, sometimes we won't be able to hear, and these things we will study in next video. So I think you would have become clear about the amplitude of vibration, oscillatory motion and vibratory motion, children. Now one more thing I am explaining for you. What we will do that, if we plot the graph for this one, oscillatory motion of pendulum, we will find that above the graph paper, once we will get the graph like this, and then in downward direction for the next side, from other side of extreme position. So for plotting the graph for this one, what will happen? We will get the graph like this. So one elevation and one depression together will form what? One oscillation. It will show one oscillation. Time taken to complete this one is called one time period. And this one will represent what? Amplitude. Is it? Okay, children. So again I will make you understand this thing in next video. So and the video will become long and you won't be able to watch so long video. So go on. We will keep on studying smaller topic, and then you will be able to understand also. Thank you for watching this video, and if you like this one, if you understand this one, then subscribe it and like it also, children, so that my hard work after the school can get awarded. Thank you very much.